Now we're going to start looking at expanding brackets, but before that we're going to explore some special patterns. So we're going to create special binomial patterns and look at a connection with expanding brackets. So if I asked you to find 1, 0, I would hope you know that's 1 factorial over 0 factorial, and the difference between them is 1 factorial. So it's 1 over 1 times 1, which is 1. In that case, what would 1, 1 be? That would be 1 factorial over 1 factorial, and the difference between them is no factorial, 0. So it's 1 over 1 times 1, which is 1. 2, 0 would be 2 factorial over 0, and the difference between them is 2. And then that goes to 1 as well. 2, 2 would be 2 over 2 factorial, and the difference is 0. It's the same, isn't it? Just the other way around. We'll just go to 3 factorial over 0 factorial, and the difference is 3, and then we get 1 out. And lastly, 3 factorial over 3 factorial, and the difference is 0. They can reduce down, and you get times 1, and you get 1. So you'll notice I could give you anything, and it should give you a 1 outlet if it's in this condition. That means that if we start thinking about the pattern, all of these have a value of 1. The number 1 appears at the top at each end of the subsequent rows. I'm going to show you the full picture in a minute. We're just starting to get the idea of a pattern. So any of them, no matter what row, if we have n factorial over 0 factorial times the difference between them is n, then what happens is that's n factorial. 0 factorial is 1 over n factorial, and they cancel down, and you get 1. So no matter what I put there, I end up with 1. Okay. So if we know that all of those are 1, what about the middleman? So we've got 1, 0 and 1, 1. We've got 2, 0 and 2, 2, but where's 2, 1? So let's go for 2, 1. That's 2 factorial over 1 factorial, and the difference is 1. So that is 2 over 1, which is 2. 3, 0, 3, 3, what happens in the middle? So what's 3, 1? 3, 1 is 3 factorial over 1 factorial, and the difference is 2 factorial, which is actually the same as 3 factorial over 2 factorial times 1 factorial, which that one is the same as 3, 2. So they both must be the same. Now remember that was 6 before, so 6 divided by 2 times 1 is the same as 6 divided by 2, which is 3. So let's have a look at the picture a bit more now. Before we do so, for the first part of the pattern, we need to have 0, 0. We only use natural numbers for n, so this disobeys our normal binomial coefficient rule, but it is used to help explain the following pattern we're going to look at. So if you had 0 factorial over 0 factorial, and the difference between them is 0, remember they're not 0, they're 1s, so it's 1 over 1 times 1, which is 1 as well. Okay. Pascal's triangle is what I'm trying to get you to see. So Blaise Pascal was credited with this, and it helps solve a lot of issues for us. So what he has done is made up integers to do with binomial coefficients, but actually it's a nice relationship in a triangle as well. Row 0 means that you have 0, 0. Row 1 is made up of 1, 0, and the other partner is 1, 1. Row 2 is made up of 2, 0, then you've got 2, 1, then you've got 2, 2, 3, 0, 3, 1, 3, 2, 3, 3. Okay, so you always have a 0 to start with and finish with the same value as n. Remember what 0, 0 was? It was 1. And then you had 1, 0 and 1, 1. And remember 2, 0, 3, 0, 2, 2, 3, 3. What happened in the middle? We got 2. What happened? We got 3. We get 3. Do you notice anything? What does 1 and 1 make? 2. What does 1 and 2 make? 3. What does 2 and 1 make? 3. So actually, Pascal's triangle is a really, really fast way of finding what each binomial coefficient is by just following this pattern. So every first part will be 1, every last part will be 1, but then to find the middlemen, if you like, we need to consider adding the 2 terms above it. What you're going to do is try and complete a Pascal triangle. If Scholar doesn't work for you, because we don't know if you're signed up for Advanced Higher yet, then you can use page 18 to 20 to work through, or you can basically go back and just start that pattern and finish it off and go down to about the 9th row, okay? So you could have that at the front of your jotter or whatever, so you can always look at it. Okay, the rows are numbered from row 0, and there's an activity online I'm going to show you, and the numbers in the body of the triangle follow the rule to find a number, add the 2 numbers above it to the right and left of it. Okay, so I'll bring this back up in a sec, but just to show you, if you could access Scholar, remember that if you go into, you should have higher on it, but I've been led to believe that you should have advanced higher on it now. I'm not sure on that. Not go to the book, go to the resources part. And if you click on that, what it will do is take you to this. These might be closed. For me, they were all open. So the course materials, what you have to do is scroll all the way down and find binomial theorem. You'll find it's here. And what we're looking for is activities. So we're looking for interactivity, and we're going to go to Pascal's triangle. Okay, so what we're going to do is click on Pascal's triangle. There's also a video there if you're interested to see about 0 factorial equaling 1. But what we're going to do is just go to Pascal's triangle. You can't do the others yet, okay? So just ignore that. When you get there, you should open up and you'll have instructions and so forth, but all you're going to do is try and put the numbers in. So you know it's a 1, you know the ends are 1s, and then you've got 1, 2, 1, and so forth, and see if you can fill it in. You can go forwards and backwards, that's the last. You can't go, if you click that, it should change where you are on the pages for this, and you can enter the numbers onto the triangle itself. If you scroll down, you'll get the binomial expansion part, and you've to put in just the numbers from Pascal's triangle. If you want to reload, it will try it again. If you want to reveal, it will tell you some answers. And you can see it goes further down. If you can't access this, then you can just draw a big giant triangle yourself. Make sure you start with one at the top centre of the page, and then you can always reflect on it. Okay, and you can also view the video link for 0 factorial if you can access the Scholar. Okay, so if you can't access the Scholar, then just try to draw me a big triangle using the pattern. Otherwise, you can go through every single part of 18 to 20 in the PDF, but I think the activity will be more enjoyable than going through the 18 to 20. Okay.